Chapter 2. The Microscope. In the year 1600, the world was filled with creatures great and small, and the smallest were the gnats and fleas, as they had been since history began. Every once in a while, someone, perhaps a squinting nearsighted person or someone with a weak magnifier, would observe tiny specks on a rind of cheese, or on someone suffering from chronic itch, and he or she would claim that these almost invisible motes were actually alive. But they offered no proof or even convincing evidence. The authorities denied the existence of living specks, and everyone else ignored these wild claims. In the year 1600, humanity was still suffering from sporadic storms of deadly epidemics, with no clue about the true cause, and little power to evade them. London had lost over 20,000 of its residents during an outbreak of bubonic plague in 1563, and the plague was endemic in Constantinople for most of the 1500s. Neither the ancient Greeks nor any subsequent scientists had made much progress in discovering the ultimate cause of such natural disasters, much less in devising any kind of cure or prevention. Mankind was still helpless against the wrath of pestilence. But in 1543, But 1543 was the year Copernicus published his theory about the Earth circling around the sun, and by the year 1600, the scientific revolution had begun. The two lens trick. If you have a transparent sphere, perhaps a glass bowl filled with water, or a large glass marble, and you look through it at something on the other side, the object you are looking at appears enlarged. This effect has been known for thousands of years. Reading stones and magnifying glasses are just reduced versions of transparent spheres. These simple magnifiers can be fun and beautiful toys to play with, but they only make things look a few times larger at most, and for most of history they were used mainly as a reading aid or an assistance for people with aging eyesight. By the year 1600, Dutch spectacle makers had become proficient at grinding and forming a variety of quality glass lenses, both concave and convex. One can imagine children, or adults, wandering through the workshops playing with the lenses and trying to see what happens when you look through two lenses at once. Many of these people probably found only blurry colors and quickly give up. But a few of them discover that if you arrange the lenses just so, you are treated to something remarkable. Try holding a concave lens, maybe somebody's corrective eyeglasses, over your eye, and hold out a weak convex lens, i.e., a weak magnifying glass, in front of it. Try lining up in your sight and looking through the pair of them at something far away. As you adjust how far away you hold each of them, you might discover that they make the distant object look closer and larger. Or look at a fly with a strong magnifying glass, then place a weak concave lens over your eye. With the right adjustments, you should be able to make the fly look even larger than you could with only the magnifying glass. Using a pair of lenses in the right way, you can extend the power of a simple magnifying glass. You can upgrade a toy into a powerful optical instrument. These discoveries were apparently made by several people independently within a decade or so of 1600. The first written documentation is a patent application filed by Hans Lippershey in 1608, but two lens magnifiers may have been in use as early as 1590. In about the year 1600, a scientific giant in Italy learned of the new Dutch two-lens magnifiers. This visionary man instantly saw the scientific potential of both kinds, the far-seer and the small-seer. He figured out how to manufacture his own optical instruments, and then he used them to see things that no human eyes had ever seen before. Galileo Galilei was most interested in the ability of the far-seeing device to extend his eyes into outer space. He had devoted his life to proving the Copernican theory of the solar system, and he realized how important this new instrument could be in supporting his case. But he also rejoiced in the tiny wonders revealed by his ocellino, or little eye. Putting a housefly in front of his little eye, Galileo observed the fly's bizarre compound eye, and he discovered how the fly could walk on walls and ceilings without falling off. He later gave one of his ochellinos to Federico Chesi, a young friend. This young admirer of Galileo's new world-observing, instrument-trying spirit, and at the age of 18 he gathered together some like-minded friends and founded his own club. It was probably the first science club in history. Chesi named his club the Accademia dei Lincei, using the sharp vision of the lynx as a symbol for seeing nature clearly, and he devoted the rest of his life to his clear-seeing academy. Galileo became a proud Lincean, and it was members of this academy who gave Galileo's new vision-extending instruments their modern Latin names. To the far-seer, the Linceans gave the name telescope, and to the small-seer, they gave the name microscope. In the years following Galileo's death, the telescope became very popular and underwent rapid development. The microscope did not. The Linnean Society produced a few drawings of sights seen under the microscope, but sadly it evaporated shortly after the death of its founder. The microscope had not revealed new worlds, and it remained a novelty, a slightly more powerful magnifying glass, for decades. The first microscopist. Galileo had helped to plant the seeds of an intellectual revolution, but these seeds took a while to sprout. In Italy, at least, authorities still had firm control over the proper views of how the world works. Galileo's imprisonment for contradicting doctrine was still a fresh memory, and everyone else with a desire to explore the natural world and to see it clearly for themselves had to keep their mouths shut or risk a similar fate. But around the year 1660, a new crop of Galileo's intellectual descendants began to grow. Here and there, in scattered corners of Europe, a few rogue explorers started adding lights and mountings to their microscopes. They started making careful, systematic explorations of their improved instruments, and they started discovering new truths. At least two of these pioneers figured out how to use a microscope to look inside a body and how to perform tiny dissections under a microscope, and they invented microscopic anatomy. At least two of them discovered the capillary blood vessels that linked the ends of arteries with the ends of veins, thus providing the conclusion to a different story, the discovery of the circulatory system. Several of these microscope pioneers were talented artists, and they created beautiful color illustrations to show others what they saw. These 5 pioneering microscopists worked mostly independently, but sometimes they met or corresponded, and they were all active around the same time from around 1660 to 1690, 2 of them in the Netherlands, 2 in England, and 1 in Italy. The Italian was Marcello Malpighi. He mapped the anatomy of the silkworm, previously thought to be too small and simple to have internal organs, and he helped to discover the lymphatic system, which was later discovered to play an important role in protecting us from germs. He is also the one usually given credit for discovering capillary blood vessels. The Englishmen were Nehemiah Grew and Robert Hooke. Grew used the microscope to search for fundamental similarities between plants and animals, hoping to discover unity in God's creation. He found it in the realization that flowers are actually a plant's sexual organs. Robert Hooke was primarily a physicist, but his 1665 picture book of sights seen through the microscope was arguably the first scientific bestseller in history. Perhaps one could say it went viral. Hooke's micrographia included 38 plates and gave the astonished public its first view of a monster-sized gnat, a flea, and a louse clutching a human hair. And those specks on cheese? They really are tiny bugs, cheese mites. The specks on itchy patients are scabies mites. Those would be discovered a few years later. Of the two Dutchmen, one was Jan Swammerdam, who performed tiny dissections and made beautiful paintings of them, and like Malpighi, helped to invent microscopic anatomy and discover the lymphatic system. Robert Hooke's Micrographia was also the inaugural publication of a new science club in London, the Royal Society. Federico Cesi's devotion to seeing nature clearly had faced opposition from authority, and this opposition may or may not have played a role in his academy's downfall. The new science club in London defied authority publicly in their motto, Nullius in verba, or take nobody's word for it. The Royal Society's membership included Hooke and most of the other pioneering microscopists. It would go on to include many of the subsequent doctors and scientists in this story, and the Royal Society remains a prestigious institution today. Antony van Leeuwenhoek. The remaining Dutchman was Antony van Leeuwenhoek, and it was Leeuwenhoek who made the first major discovery on the way to understanding infectious disease. If you say Leeuwenhoek, you might not sound like a native Dutchman, but you'll be pretty close. Leeuwenhoek was a businessman by profession, but he spent all his free time making and using microscopes as a personal hobby. Unlike the others, he did not use the two-lens trick. Leeuwenhoek chose a different design of microscope, a single-lens design that amounts to a very tiny but very powerful magnifying glass. You can see how it works using a small clear marble as a lens. Here's a Leeuwenhoek microscope I made by bending a paper clip into a handle for a marble. With such a device, you can make things look quite large by holding the marble up close to your eye and holding the thing you want to look at close to the other side. You may need some strong light in front of you to obtain the best pictures. I took a picture of a bee's wing by taping the wing to a window on a sunny day, holding up the marble in front of it, and holding the lens of my iPhone camera in front of the marble. After a little juggling, I managed to capture this. A marble magnifier gives you a better view of things you could already see, but it probably won't show you any new forms of life. The marble magnifies more than a large magnifying glass because the marble is so small, but to see really tiny things, you need really tiny lenses. Leeuwenhoek was able to see things far, far smaller than anyone had ever seen before because he figured out how to make really, really tiny lenses. Instead of the two-lens trick, Leeuwenhoek used the tiny lens trick. Leeuwenhoek perfected the art of grinding and mounting his tiny lenses. He invented ways to mount specimens against the lenses, and he designed a way to make delicate movements of the specimen using fine adjustment screws. Leeuwenhoek's movable mechanism were the forerunners of the modern microscope stage. Leeuwenhoek's handheld microscopes were more awkward to use, but they were more powerful than the two-lens microscopes of his contemporaries. And with them he observed something remarkable, something completely new, something none of the others had ever seen or even dreamed of. We know about Leeuwenhoek's discoveries mainly through the numerous letters he wrote, mostly to the Royal Society of London. In one of these letters, dated 1674, he describes some beautiful wispy green streaks that he had observed one day in local lake water. From his careful description, we now know these wisps to be the lovely Sporagea algae. But he also saw something strange around the wisps. Things were moving. just waving in the currents, but zooming across the window, or waddling strangely, or just whirling in circles. Some of them moved almost as if they were feeding on the algae. Swarming around the Gira, Leeuwenhoek saw things far smaller than any speck of dust, but they swarm and behaved just like living creatures. Leeuwenhoek had discovered minuscule animated animals, far smaller than any that had been known to exist before, swimming and dancing and zooming around the algae. Leeuwenhoek wrote exclusively in his native Dutch, and the word he used for these things, the diminutive for animal, is traditionally translated into English as animalcule. Leeuwenhoek wrote, quote, "And the motion of most of these animalcules is in the water is so swift and so various, upwards, downwards, and around about, that 'tis wonderful to see, and I judged that some of these little creatures are above 1,000 times smaller than the smallest ones I have ever yet seen upon the rind of cheese." Unquote. If you own a microscope, it is not too difficult to find some of these creatures and see them for yourself. I found some creatures in the algae growing in a horse's water barrel, and I took the following picture of them using only my iPhone and a hobby microscope. If you don't own a microscope, it's not hard to make one similar to Leeuwenhoek's. If you can handle a little light work with a glass rod and a flame, and most people can, I recommend the simple but elegant method explained by Patrick Keeling. You can also buy a very inexpensive pre-made Leeuwenhoek style microscope from Foldoscope. Galileo Galilei and Antony von Leeuwenhoek both made their own optical instruments and taught themselves the skill of using their new devices, and both of them discovered new worlds through their instruments. Thanks to the telescope he built, Galileo was the first person in history to witness the phases of Venus, the moons of Jupiter, and the mountains on the moon. Thanks to the microscopes that he built, Leeuwenhoek discovered a new world of his own, a world that nobody had known or even suspected before, a world filled with new, bizarre, alien creatures, right in our own backyard, but incredibly small. Leeuwenhoek discovered the microcosm. Leeuwenhoek spent much of the rest of his life searching for, finding, and studying his little animals. Children delight in pets and in trips to the zoo. Leeuwenhoek delighted in the tiny zoo he had discovered inside his microscope. He searched every sample of water he could reach: lakes, the sea, his roof gutters, his well, the Delft canals, drain pipes, and he described new creature after new creature. From his careful description, modern students of science might recognize rotifers, Vorticella, Euglena, and Hydra. He even found tiny little animals inside other animals, in his own mouth, for example. In one paper, he described his daily habit of cleansing his teeth and how it left behind, quote, "a little white matter which is as thick as if it were a batter. In the sad matter there were very many little living animalcules, very prettily a-moving." Unquote. He provided a few sketches and described how they shot through the water or spun round like a top. Leeuwenhoek was also the first person to describe the red oval corpuscles in blood and the wiggly little things in seminal fluid. To the best of my knowledge, however, he never associated any of these things with disease. Wherever he found them, animalcules were like the red blood cells, just natural residents in the place where they belonged. Leeuwenhoek never stopped exploring his microcosm, and his diligence is one reason he holds a much loftier place in the history books than those in earlier centuries who claim to have seen living dust specks. Leeuwenhoek asked and then tried to answer as many follow-up questions as he could. How big are these little animals? They come in a range of sizes. Leeuwenhoek chose a few of them to analyze, and then he carefully compared them to known objects, and he calculated ratios. They were astonishingly small. Quote, "This creature is 1,000 times smaller than the eye of a louse." Unquote. In rough terms, these new creatures were as much smaller than lice as lice are smaller than human beings. Where do the little animals come from? Leeuwenhoek tried an experiment. He collected some fresh rainwater straight from the sky in a thoroughly clean vessel and found nothing. But when he checked again a few days later, little animals had appeared. Although with a few bits of dust and lint, he doubted they had magically appeared from nowhere, but he was a practical man, careful never to jump to conclusions. For now, the question of where the animalcules came from didn't have a convincing answer. What do the little animals eat? In a different experiment, Leeuwenhoek prepared various infusions of ground pepper, ginger, cloves, nutmeg, and vinegar, hoping to discover what causes each of them to taste the way they do. Was the sharp taste of pepper due to sharp spikes or edges on the grains? After a little time, he discovered swarms of animalcules in these infusions, and thus he accidentally discovered how to feed microbes. To this day, infusions of stuff from your lawn are a good way to grow crops of microbes to put under your hobby microscope or to feed your pet fish. For many years, this entire new category of life was officially named Infusoria. How does animalcule anatomy work? They have no muscles or limbs, but nor any apparent brains or stomachs or hearts. The eunuch was fascinated by the organs of motion, or lack thereof. These bizarre creatures were clearly capable of rapid and agile motions, but they had no apparent means of propulsion or guidance. In a few of the larger creatures, the eunuch could see what looked like hair or maybe tentacles sticking out from somewhere, but he never saw anything normal like fins or flippers. The eunuch had discovered a new world of life, but without Robert Hooke, history might have written him off as a charlatan. Leeuwenhoek was perfectly willing to let people look through his instruments to see what he saw, but nobody could see these incredible new animalcules except through Leeuwenhoek's personal handmade microscopes, and he refused to share his special techniques for making them. Some people questioned his honesty, or his competence, or at least his eyesight. But at the request of the Royal Society, and after 3 attempts, Robert Hooke finally managed to produce microscopes equal to Leeuwenhoek's. Hooke finally demonstrated to the Society that everything Leeuwenhoek had claimed was true, and he showed the rest of the world ways they could see things for themselves. Hooke brought proof to the world of the existence of microscopic animals. The zoo under the microscope. Birds, reptiles, insects, mollusks. The inventory of creation needed a new branch now. Leeuwenhoek had added an entirely new wing to the world's zoological garden, the Infusoria. Today we call them more formally and more broadly the microorganisms, or microbes for short. The tiny occupants of this wing of the zoo come in all shapes and sizes, from the larger ones with a few visible parts to the tiniest simple living shapes, often straight sticks or round spheres. And they exist everywhere we look in the natural world, living and swimming in every kind of moist matter, even inside other living bodies. Normal animals come in all shapes and sizes, each of them fitted to its own kind of lifestyle. Some of them make a living by feeding on other animals. If a larger animal kills and eats a smaller animal, we call them predator and prey. Sometimes a larger animal hitches a ride on or in a larger animal, and it makes a living feeding off the larger animal without killing it. We call them parasite and host. What about animalcules? Sometimes we find them living inside other bodies. Could they be microscopic parasites? Could we explain disease by saying that some of these microbes find a way in and make a parasitic living inside our bodies? Could parasitic microbes be the seeds or germs of disease? Perhaps. But even if we searched and found foreign microbes inside us, how could they possibly be causing any harm? They're so small, they have no effect on our sense organs. So how could they cause any damage to our lungs or our stomachs? Some people could try to claim that microbes were the agents of disease and that the something out there that causes plagues and epidemics was actually microscopic life, but they were only guessing. There was no proof, nor even any evidence to support the claim. Surely microbes in a microscope are like the flakes in a snow globe, pretty to watch, but of no practical consequence? For almost 2 centuries after Leeuwenhoek's discovery, this is how most of the world viewed microbes. They were known to exist, but they inhabited a different dimension. They were like mythical beasts, existing only in the world inside a scientist's microscope. It was a curious world, a fun to visit world, but also a useless and unimportant world, of no significance outside the window.